Now that we've performed some of the preliminary calculations necessary for our flight planning, let's see how this information affects the real-world conditions of our flight. Without knowing what heading we need to fly, based upon variable wind directions and velocities, it is likely that we will not make it to our destination in a straight-line fashion. Keep in mind that the course is actually the track of the aircraft across the ground, while the heading is the direction in which the aircraft is pointed. The course and heading will only be the same if there is no wind. Consider this, for example. The course that we plotted on the sectional chart will be 360, and the winds are predicted to be out of the west at 270 at 31 knots for our planned altitude. If we flew a compass heading of 360 without accounting for any wind correction angles, the wind would eventually move us off course and we would miss our destination. Depending on the wind conditions and the distance to our destination, we could be very far off course and never find the destination. For every degree that we are off course for a 60 nautical mile flight, your aircraft will be 1 mile away from our target destination. So if we are 20 degrees off course, we will be 20 miles away from our destination, only for a 60 nautical mile flight. Longer flights will only aggravate the situation. 10 degrees off course over a 100 nautical mile flight would put us over 17 miles away from our destination. Let's try an example. Select HDG/GS from the menu for heading and ground speed. We will input the wind conditions and the course we intend to fly, and the results will tell us what our actual heading should be for any crosswind correction, as well as what our ground speed will be. Enter 270 at the wind direction point, just to be consistent with our last example, and press Enter. Now, enter 31 for the wind speed in knots, taken from the winds aloft chart from our intended route of flight. Now, enter the course for this flight, based upon the sectional chart. We will use 360 in our example. Once you press the Enter key, you will see something that may surprise you. If you had performed the previous function on your E6b using the values that were discussed, you will see that the E6b automatically entered the true airspeed of 147.76 for you, taken from the results of the last function. This feature is a benefit for more efficient flight planning, and the values will be retained even if the unit is turned off. If you do not see the true airspeed value or would like to change what was retained, simply enter the number 147.76 at the flashing TAS or true airspeed prompt, followed by the Enter key. As you can see, the question of heading and ground speed are quickly answered. If you use the same values, you should see that your actual speed across the ground will be 144.5 knots, and in order to maintain your selected course of 360 degrees, you will have to use a heading of 347.9, or simply 348 degrees, to account for the crosswind.